Mass number, or AMN for short, is the total mass sum of any and all protons and neutrons in the nucleus of an element on the periodic table, and a mass that is approximately equal to the whole number sum of protons and neutrons in the nucleus. So we basically have two definitions here. First thing you need to know is that it is a total mass sum of all the masses of the protons and neutrons in the nucleus of an element on the periodic table. So here let's take a look at the periodic table of elements, and we're going to look at an example called iron on the periodic table. So iron is here, it's number 26 on the periodic table, and so we're going to take a look at iron here. And if we blow up this box, then what we see is this number in the upper left corner, 55.845, and that is your atomic mass number, or AMN for short. So what you need to do is you need to add up the mass sum of the protons and neutrons in the nucleus, which they come up with as 55.845. So now we can round this up, and this brings in the second part of the definition, which is an approximately equal to the whole number sum of protons and neutrons in the nucleus. So we're going to round this up to number 56. So we have the total number is equal to 56. Let's put a total here. TOT. And that total number, we're going to round it up to 56. Now the atomic number is going to be given by this 26 right here. So that's the atomic number, which we'll call AN for short. And that is equal to the total number of protons. So if we look at the number of protons in iron, that is going to be equal to 26. So this 56 is equal to the number of protons, approximately equal to. So we'll put an approximately equal to in here. Number of protons plus the number of neutrons. So we know 26 of these is going to be the number of protons. So all we need to do is solve for the number of neutrons. So we've got 56 is equal to 26 plus the number of neutrons. So if we do some simple math here, we can determine that the total number of neutrons has got to be equal to 56 minus 26, which is equal to 30. And that is the total number of neutrons in the nucleus of an iron atom. So if there are 30 neutrons, and there are 26 protons, and that sums to 56, we can see that the masses, when you sum all the masses, it's approximately equal to just the whole number sum of the number of protons and neutrons in a nucleus. If we look at hydrogen, for example, it's number 1 on the periodic table, telling us there's 1 proton in the nucleus. If you look at the atomic mass number, it's about 1 as well. So it's telling you that there are no neutrons in the nucleus. Let's look at helium over here. It is number 2 on the periodic table. That atomic number 2 tells us there are 2 protons in the nucleus. If you look at the upper left number, it is about equal to 4. And so that is the total number of protons and neutrons. So it's telling you that there are 2 neutrons in the nucleus and 2 protons in the nucleus. And when you add up the number of protons and neutrons, the atomic mass number is about equal to 4.